Well, guys, we're back again. I hope you're enjoying your time here flying, and I hope you're learning a lot. So this week we are going to cover the heart of what you will be needing to know as a pilot, and that is Metars, Tafs, and Atis reports. Now, these are the reports that's going to give you the current conditions of your airport. It's going to give you the forecast for the airport, and it'll give you all the pertinent information for the aerodrome that you're going to be operating in. So without further ado, let's jump right into it, okay? Let me get this back to where I need it to be. All right, little technical difficulties this morning. Give me just a second. All right, now we should have that fixed. So let's jump into this, all right? So let's look at some definitions of what you need to know about these things, okay? Observations are raw weather data collected automatically by sensors, manually by trained weather observers, or a combination of the both. The observations can either be in situ or in situations. That refers to the surface or airborne, or remote by weather radar, satellite, ground and lightning sensors, things of that nature, okay? Now, analysis is a representation of atmospheric variable, i.e. temperature or pressure, derived from a finite set of irregularly distributed observations onto a regular grid. Analysis of weather information are enhanced depictions and or interpretations of observed weather data. Now, advisories, aviation weather advisories, including warnings and alerts described in this handbook, which I'm taking this from the FAA's handbook, okay, are primarily produced by the National Weather Service. They inform the pilot and or the operator about aviation weather that may be a factor to the safety of a flight, or that may need mitigation or avoidance depending on the aircraft and or pilot certification, current operating limits, or capabilities. Now, a forecast, we all know what a forecast is, but these are predictions of the development and or movement of weather phenomena based on meteorological observation and various meteorological models. The handbook describes many of the forecasts primarily produced by the National Weather Service that are either specific to aviation or the public products of interest to aviation users. Okay. Now, aviation weather trends are web-based applications that incorporate multiple weather products into a web-based interactive display. So let's talk about observations for a minute. Now, you can have several different types of observations, okay? You can have surface observations, train weather observations, aircraft observations, satellite observations, upper air observations, or a sounding, where they send the weather balloon up and take recorded measurements of the atmosphere. Or you could just have aviation weather cameras. Surface observations. Now, surface weather observations are fundamental to all meteorological services. It tells us what's happening on the ground. Observations are basic information upon which forecasts and warnings are made in support of a wide range of weather-sensitive activities within the public and private sectors, including aviation. There are three general types of surface observations, okay? So you have manual, automated, and augmented. So let's talk about what a manual observation is. A manual surface observation, it observes weather. Well, it's hard for me to see. Let me blow this up. All right, there we go. I can see it now. Manual surface weather observations are made by human weather observers who are certified by the FAA. While manual observations were the primary type prior to the mid-1990s, Automated and augmented observations make up a vast majority of today's surface observations in the United States. Now, an automated observations are derived from the instruments and algorithms without human input or oversight. In the United States, there are two main kinds of automated observing systems. You have the ASOS, which we have out at the airport, or the AWOS. Automated observations contain auto in the report unless they are augmented by human weather observers. So what's an augmented observation? Augmented observations are at select airports in the United States. The automated observing system will have input oversight by human weather observers or tower controllers certified in weather observing. They are referred to as augmented observations. Human observers report weather elements that are beyond the capabilities of the automated system and are deemed operationally significant. The weather elements observed and reported by human observer vary depending on the report. Auto is not used in an augmented report. So if you ever get a Metar or something like that and it says, if it's augmented, it will not have the word auto in the typed out version, okay? All right, here we go. So Automated Surface Observation Systems, ASOS. The ASOS program is a joint effort of the National Weather Service, the FAA, and the Department of Defense. ASOS serves as the nation's primary surface weather observing network. ASOS detects significant weather changes, disseminating hourly and special observations. Additionally, ASOS routinely and automatically provides computer-generated voice observations directly to the aircraft in the vicinity of the airport using FAA ground-to-air radio. These messages are also available via telephone. ASOS observers, formats, archives, and transmits observations automatically. ASOS transmits a special Chapter 24 Observations 24.3 report when the conditions exceed pre-selected weather element thresholds, something like the visibility going down. All ASOS locations prepare and disseminate Metars or species in accordance with the format prescribed by the FAA. ASOS 1-minute observations, or OMO. In addition to the ASOS Metar species are ASOS OMOs, which are updated once a minute. OMOs can be in various formats and are sometimes encoded in the Metar format. ASOS broadcasts can be different from the Metar seen on the internet or FISB, since a broadcast is the OMO ASOS data. The OMOs are not instant weather. Rather, the clouds and visibility are time averaged, so 30 minutes for clouds and 10 minutes for visibility. The average algorithms are designed to report deteriorating conditions much quicker than improving conditions, so you need to remember that. So ASOS reporting. ASOS reports the following basic weather elements: sky condition, cloud height, and amount. So you'll see that as clear, few, scattered, broken, overcast, up to 12,000. Future upgrades may raise that height limit. Visibility to at least 10 miles. Basic present weather information type and intensity for rain, RA, snow, SN, freezing rain, FZRA, or unknown precipitation, UPs. Now these, I want to pause right there just for a second. So all of these abbreviations you can find on the FAA website, okay? It would behoove you to go look at those, possibly download them and learn them. Because if you see something that says TSRA, you need to know what that means. If you are reading a Metar and you see something that says BR or mist, you need to know what that means. And on your check rides, it's very likely that they will present you with a METAR or have you to read a METAR, and you need to know what these abbreviations are. If you do not know what they are, you're not going to be able to tell the examiner what they are, and then guess what? He's going to really start getting hard on you, okay? So take the time and learn these and know what they are. All right. So thunderstorms on site is TS, or in the vicinity is VCTS. Obscurations to visions such as fog, FG, mist, BR, and haze, HZ. Now note, fog is reported when visibility is less than 5/8 of a statute mile. If it's more than 5/8 of a statute mile, it will not report fog, okay? Freezing fog, FZFG, is reported when the temperature is below zero. Mist or haze is reported when visibility is from 5/8 statute mile to less than 7 statute mile, depending on the difference between the temperature and dew point. If the difference is 4 degrees Fahrenheit or about 2 degrees Celsius or less, then FG is reported. Otherwise, HZ is reported. Pressure, sea level pressure, and altimeter setting. Now, those are very important. You need to know how high off the ground you're going to be. You got to put that in your altimeter, right? So, temperature is going to be reported ambient temperature and dew point temperature. Wind direction, from which way the wind is blowing, speed and character, gust or squalls. Now note, National Network Distribution, FSS internet, and FISB of wind direction are in true degrees, while local dimensions, radio and telephone, are in magnetic degrees. Now, I want to pause right here just for a second, and you need to understand something about this specifically, okay? Now, there's a little saying that I like to say that helps me remember this very easy. And so I'm going to clear the slides off the board, and I want to see if I can depict this to help you remember it, all right? So if we have the Earth here, we have the Earth. We know that the Earth is surrounded by electromagnetic waves. Okay? So we know that the Earth is surrounded by electromagnetic waves. We have a pole here and a pole here, and these things go from outwards and surround the Earth around the poles. Okay? So I want you to think of it this way. If the Earth has magnetic energy around it, i.e., electromagnetic waves, it would serve us well to understand that if something such as a weather reporting system that's my weather reporting system if you can't tell, it would serve us well to know that if it touches the ground, it's going to be magnetic. All right? If it touches the ground, it's going to be magnetic. Well, Shannon, what are you talking about? What's that going to make? How does that apply to what you're saying? All right. So, we have our runway. This is 3, and this is 2-1. Okay? The runway is touching the ground, right? So how do they come up with 2-1 and 3? Magnetic. 2-1 and 2-3 is a magnetic source that they use to assign runway numbers with. The runway touches the ground, it's magnetic. Okay? Now, when you get a report over the radio, it's coming from that ground-based observing station, right? So if it comes from that ground-based observing station, it touches the ground, so that means it's magnetic. I can't stress this enough. If it touches the ground and you get a wind report from that thing that's touching the ground, that weather station, it's going to be in magnetic degrees. Okay? Well, what if you're getting a report off of ForeFlight or Flight Weather Service or something like that? Well, if you hear a wind direction, it's true. If you hear it, it's true. Oh, I'm sorry, I just told you wrong. If you read it off of something, it's true. But if you hear it, it's magnetic. It's early in the morning, you'll have to forgive me. But if you read it, ForeFlight, computer, something like that, it's true. If you hear it, it's magnetic. Well, Shannon, I'm still lost. I'm confused. What are you talking about? All right. So when by now, all of you have been flying, and you know before you go up, you tune in 121, 575, and that's our AWOS out here at the airport. So you tune up and you hear that the AWOS tell you all the weather information. You're listening to it, you hear it. So the wind, therefore, is magnetic. Direction. Okay? So you're hearing it, so that wind is of a magnetic direction. So if you hear the wind is 240 at 8 knots, well, that 240 is coming off a compass direction, magnetic direction. Okay? But let's say you're getting ready to go on your cross countries, and when you get ready to go on your cross countries, you're going to have to do a weather briefing, right? Well, on that weather briefing, it's going to give you the wind directions along your route of travel and all of that. So now you're on a computer, and you're reading this on the computer, right? Well, since you read this on the computer, that means that wind is being given to you in true direction. Well, Shannon, I'm still confused. What's the difference between magnetic and true north? All right. This is pretty simple, okay? So like I said, the Earth has poles. We got a North Pole, we got a South Pole. Magnetic direction is the magnetic direction that points to the North Pole. So if you point to the North Pole, or any cardinal direction, any direction period. So if you get a magnetic direction of 360, that's pointing to the North Pole. If you get a magnetic direction of 180, that's pointing to the South Pole. And it does the same for east, west, and anything in between, okay? So just know, and in Clinton's class, you're going to learn about magnetic variation. There's lines on your VFR sectional chart of magnetic variation. And all magnetic variation is the difference between true north and magnetic north. That's all it is, okay? So just understand that if you read a wind direction, it's true north. If you hear a wind direction, it's magnetic. Now, the further you go on into your training, especially in your instrument rating, you're going to really get a grasp of this, okay? So for the purposes of this class, just understand that if you hear a wind direction, it's magnetic. If you read it, it's a true direction, okay? So let's jump back into our slides. All right, now this ASOS will also give you a precipitation accumulation amount, selected significant remarks including variable cloud height, variable visibility, precipitation beginning, ending times, rapid pressure changes, pressure change tendency, wind shift, peak winds, and may include density altitude. And we will have a whole class on all things concerning density altitude, because that's very important. All right, so let's talk about the Automated Weather Observation System, or AWOS. This is what we have here at our airport. Now, the AWOS is similar to the ASOS. Generally, the AWOS does not report all the elements that the ASOS does and may not have the same level of backup sensors or maintenance response levels. Regardless, AWOS provides pilots with the necessary weather information to conduct 14 CFR Part 91 flight operations, as well as others depending on the operations specifications, or the op specs. AWOS automatically provides computer-generated voice observations directly to the aircraft in the vicinity of the airports using FAA ground-to-air radio. AWOS reports are also available via telephone. AWOS may be located on airports or near ground bases or rooftop-based heliports, as well as an offshore platform or drilling ships. Okay? AWOS are either federal or non-federal. Federal AWOS units are owned, operated, and maintained by the FAA. Non-federal AWOSs are owned, operated, and maintained by the site owner. AWOS generates a METAR at 20-minute intervals and does not report species. AWOS also provides OMOs available by phone or radio. Now, the OMOs are not instant weather. I keep repeating this because you need to understand it. All it is the clouds and visibilities are time averaged, 30 minutes for clouds, 10 minutes for visibility. The averaging algorithms are designed to report deteriorating conditions much quicker than improving conditions. For example, if dense fog had been reported and then suddenly dissipated, it might take 10 minutes for the OMO to report VFR conditions. So that's why I keep repeating this, because you need to understand it. It is very important to understand that if you call this thing, it might not be completely right. It might not be exact. So you need to really understand how it works, and if you get fog, call back 10, 20 minutes later and see if it's changed, okay? Now, there are 6 types of AWOS systems. You have AWOS A. The AWOS A system measures and reports altimeter only. AWOS AV consists of AWOS A with a visibility sensor. AWOS 1 measures and reports wind data, speed, direction, and gust, temperature, dew point, altimeter, and density altitude. AWOS 2 measures and reports all the parameters of AWOS 1 plus visibility. Now what we have here at the airport is the AWOS-3, and that measures and reports all the parameters of AWOS-2 plus precipitation accumulation, has a rain gauge, and cloud height. It also has operational sensors such as precipitation type, intensity, present weather, and/or thunderstorm and lightning. The addition of an operational sensor will change the destination from a AWOS-3P to an AWOS-3PT. Now what we have is a AWOS-3PT. AWOS-4 system measures and reports everything that the AWOS-3PT does plus freezing rain. Now depending on the type of the AWOS unit, the following parameters may be measured. Altimeter, wind speed, wind direction from which the wind is blowing. Okay, it touches the ground, so it's a magnetic direction. Gust, temperature, dew point, density, altitude, visibility, and precipitation accumulation. Cloud height, precipitation type, precipitation intensity, present weather, thunderstorm, lightning, freezing rain, runway surface conditions. So now that we've seen how the weather information is collected, let's look how it's disseminated. Now this is where we go into the Metars. Now you need to know this. I cannot stress this enough. Every single check ride you go to, you're going to have to read Metars, Tafs, things of that nature. Understand what these are and be able to read them. Let me say that again. Understand what these are and be able to read them. If you do not know how to do this, you are going to have a very bad way throughout your career as a pilot, okay? So what is a METAR? So a METAR is an aviation routine weather report, and a SPECI is an aviation selected special weather report. Now the METAR and SPECI are in a coded form used for aviation surface observation to satisfy the World Meteorological Organization, or WMO, and ICAO instructions for reporting surface meteorological data. Although the METAR and SPECI code is used worldwide, there are some code differences among different countries. Each country is allowed to make modifications to the code for use in their particular country as long as they notify ICAO. Now, ICAO is the governing body of worldwide aviation. These sections will focus on METAR SPECI code as used in the United States. Now, traditionally, it was critical for pilots to know how to decode METAR and SPECIs. The majority of the current pre-flight briefing services include many weather applications provided to decode report in plain language format in addition to the coded report. Now, I'm going to teach you how to read the code. Anybody can read plain English, but pilots should be able to read the code, and that's what I'm going to teach you. Okay, so the table in 24-1 provides a sample of decoded METAR, which we'll look at in just a minute. Now, while the decoded version has been welcomed by many pilots, it's still important for pilots to know how to decode a METAR or SPECI in case the source does not provide a decoded version. That's why I'm going to teach you how to decode it. All right, so let's look at this one. Now, this is a METAR, and we're going to break it down and go through the different aspects of it, okay? So the text version says KPNS. Now that is the identifier of where the METAR is for. Now it is from the 30th, it was taken the 3rd at 0053 Zulu time, okay? The wind was 360 at 5 knots. It's 10 statute miles of visibility. That CLR means that it's clear, the sky's clear. The temperature is 30 degrees Celsius. The dew point is 23 degrees Celsius. The altimeter setting is 299.2. Now that RMK stands for remarks. So this remark says AO2. Now AO2 means that it has precipitation discrimination. If you see A01, it does not have precipitation discrimination, okay? Now, the sea level pressure is 1,013.2 hectopascals. Now, that T03000233, that is the actual temperature below, or the actual temperature that the station is reading. And how you read this is the temperature, is the T stands for temperature. Now the 0 means that it's below 100. And then you see 30. So the actual temperature is 30.0, 30 degrees Celsius. Now the dew point, you have a 0 before the 233. So that means it's below 100, and the dew point is 23.3. Heck, that's the temperature at which the air must be cooled to produce dew. So the actual temperature is 30, and the dew point is 23.3. So the 0.3 rounds down to 23, and that's why they put 30/23 up in the textual version of it. Okay. All right. Now, a METAR includes the airport identifier, time of observation, wind visibility, runway visibility range, present weather phenomena, sky conditions, temperature, dew point, and altimeter setting. Excluding the airport identifier and the time of observation, this information is collectively referred to as the body of the report. Coded and or plain language information elaborating on the data in the body may be appended at the end of the METAR as remarks. Now, the contents of the remarks section vary with manual, automated, and augmented surface observations. At some designated stations, the METAR may be abridged to include only a few of the mentioned items. METARs are sometimes referred to as hourly reports since they are routinely produced at 55 minutes past the hour. Now, I want you to be able to tell me, if I see you at the airport sometime and I say, hey, when is a METAR issued? You ought to be able to tell me 55 minutes past the hour, Shannon. You need to know it, okay? So don't be surprised if on a stage check, end of course, if you're doing it with me and I say, hey, when did they issue a METAR? 55 minutes past the hour. I want you to be able to know that. Don't tell me, I don't know. Make my head explode. Don't do that, okay? So 55 minutes past the hour are when they are issued. So let's talk about the species. The species is an unscheduled report taken when the criteria in Table 24-2 are observed during the period between hourly reports. Species contain all the elements found in a METAR. Now they're issued as soon as possible when relative criteria are observed. Whenever specie criteria are met at the time of a routine METAR, a METAR only is issued, okay? So if it's time for that system to produce a METAR and the specie conditions are present, it's not going to give you a specie, it's going to give you a regular METAR. Now, earlier in the class and in the lectures, I told you that I have provided you guys with all of these slides, right? I want you to print. I can't make you do it, but it's wise if you go and you print these things off. And especially this one right here. This one breaks down all the things needed, or all the things that are present in a METAR and specie. And this will really help you learn it. So you need to download these slides, okay? Now the specie, or the METAR specie format has two major sections. The body, consisting of a maximum of 11 groups, and the remarks, consisting of two categories. When an element does not occur or cannot be observed, the corresponding group is omitted from that particular report. So here's a METAR broken down, okay? So the METAR, it says the type of report right up at the beginning, METAR. And then the station identifier, KC, the date and time of the report. This report is from the 1st at 1955 Zulu. It is an automated report. The wind is 220 at 15. The G stands for gusting 25 knots. Now the wind is blowing 180 variable to 250. So that means that the wind is switching around anywhere from 180 to 250. So that V means it's variable. Visibility is 3/4 of a statute mile. The RVR, or runway visual range, for runway 17 left is 2,600 feet. Now the present weather says plus TSRA. That plus means that that is a heavy thunderstorm with rain. Okay? The BR stands for mist. The easy way to remember that is mist is just baby rain. BR, baby rain, BR, mist. The sky condition is overcast at 1,000 with cumulonimbus clouds. The temperature dew point spread is 2 degrees. The temperature is 18 and the dew point is 16. That's why you have the mist. The altimeter setting is 29902. The remarks, this is a precipitation discriminating station. Now the TSB 25, that stands for thunderstorm began 25 minutes past the hour. Well, what hour, Shannon? Well, look up there at the time. Okay? So the time is 1955 Zulu. So if the thunderstorm began 25 minutes past the hour, the thunderstorm began at 1925. Remember that. Anytime you see a TSB 25 or whatever number, or a TSE, or an SB, or an S or SNB, or an SNE, all that means is that that weather phenomenon started or ended 25 or whatever number it is minutes past the hour listed in the top of the METAR. Okay? Now that TS is for thunderstorms. The OHD stands for overhead. They are moving, MOV, east. And the SLP is 1,013.2 hectopascals. Okay? So let's look at some METAR examples. Now this METAR come from Mountain Home. This is the Papa, I'll get it right in a minute, Bravo Papa Kilo Airport. This METAR is from the 28th at 10:53 Zulu. It is an automated report. The winds are calm. There's 10 statute miles of visibility. Sky conditions are clear below 12,000 or 12,000 feet. The temperature is 11 degrees Celsius. The dew point is 09 degrees Celsius. The altimeter is 3007. The remarks, this is a precipitation discriminating reporting station. The sea level pressure is 1,017.7 hectopascals or millibars. The temperature is the actual temperature is 10.6 degrees Celsius, and the actual dew point is 9.4 degrees Celsius. All right, so this METAR comes from the Foxtrot Kilo Romeo Airport. It's from the 28th at 10:55 Zulu. This is an automated report. The winds are 100 at 3 knots, 10 statute miles of visibility. The sky condition is clear below 12,000. The temperature is 15, the dew point is 7. The altimeter is 3013, and this is a precipitation discriminating weather reporting station. Okay? So this METAR comes from the Delta Charlie Airport. It's from the 28th at 10:52 Zulu. It is an automated report. The winds are 170 at 14 knots, gusting 20 knots. There are 6 statute miles of visibility, and haze is reducing the visibility. There are a few clouds at 4,300 feet. There are a few clouds at 12,000 feet. The temperature is 17. The dew point is 14. The altimeter is 297. Remarks. This is a precipitation discriminating reporting station. Lightning is present distant southeast. The rain began 22 minutes past the hour and ended 40 minutes past the hour. Or otherwise, the rain began at 10:22 Zulu and ended at 10:40 Zulu. The sea level pressure is 1,012.7 hectopascals. Precipitation amount, that P, that's how much precipitation has fallen, 0. The actual temperature is 16.7 degrees Celsius, and the actual dew point is 13.9 degrees Celsius. So this METAR comes from the Mike Sierra Oscar Airport on the 28th at 10:53 Zulu. It is an automated weather report. The winds are 170 at 3 knots. There are 10 statute miles of visibility. There's an overcast layer at 700 feet. The temperature is 13. The dew point is 12. The altimeter setting is 293. Remarks. This has a precipitation discriminating, it is a precipitation discriminating weather station. The sea level pressure is 1,012.4 hectopascals, and the actual temperature is 13.3 degrees Celsius, and the actual dew point is 12.2 degrees Celsius. Now this is from the San Francisco Airport, or Sierra Foxtrot Oscar, the 28th at 10:56 Zulu. The winds were 240 at 7 knots, 10 statute miles of visibility. There were a few clouds at 400. There was an overcast layer at 900. The temperature is 13. The dew point is 10. The altimeter setting was 292. In the remarks, AO2, this is a precipitation discriminating weather station. Sea level pressure is 1,013.1 hectopascals. The actual temperature is 12.8 degrees Celsius, and the actual dew point is 10.0 degrees Celsius. So now let's talk about a TAF. TAFs are very, very important. Now, this is going to be vital when you get into your instrument rating, okay? Because as part of your instrument rating, you have to know when you need to list an alternate on your flight plan. And the way you do that is an hour before to an hour after your ETA, or estimated time of arrival. If the ceilings are less than 2,000 feet and you have less than 3 statute miles of visibility, you have to list an alternate. Well, how do you know that? How do you know if you're going to need an alternate? It's by the TAF, okay? So a TAF stands for a Terminal Aerodrome Forecast. A TAF is a concise statement of the expected meteorological conditions significant to aviation for a specified time period within 5 statute miles of the center of the airport's runway complex. You have to know this stuff. You will be asked, how far does a TAF cover? Well, it covers 5 statute miles from the centermost portion of the airport complex. I can't stress this enough. I can't stress this enough. I can't stress this enough. Know these things. If you do not know these things, you're going to have a hard time. You're going to have a bad way during stage checks and check rides. So pay attention to this, because I guarantee you, I'm going to test you on it. Okay? TAFs use the same codes that you see in a METAR. TAFs are issued by the National Weather Service weather forecasting offices for nearly 700 U.S. airports. The majority of TAFs are 24-hour forecasts for that airport, while TAFs for some of the nation's busiest airports provide a 30-hour forecast. Now, there's only like 32 airports in the United States that has the 30-hour format. Normally, TAFs are only 24-hour TAFs, okay? So just be able to tell me that TAFs are 24 hours, but at some airports in the United States, they go up to 30 hours, all right? So the report type header always appears as the first element in the TAF and is produced in 3 forms: a routine forecast or a TAF, an amended forecast or a TAF-AMD, or a corrected forecast, TAF-COR. TAFs are amended whenever they become, in the forecaster's judgment, unrepresentative of existing or expected conditions, particularly regarding those elements and events significant to aircraft and or airports. An amended forecast is identified as TAF-AMD in place of TAF on the first line of the forecast text. Now, this is the same format as set up in the METARs. The location identifier will be a 4-letter identifier. After the line containing either TAF, TAF amended, or TAF corrected, each TAF begins with its 4-letter ICAO location identifier. Examples: Dallas-Fort Worth is KDFW, Anchorage, Alaska is PANC, and Honolulu, Hawaii is PHNL. Now I want to pause just for a second, get you to understand something if you haven't grasped it yet. Now, the lower 48 states is known as CONUS, C-O-N-O-U-S. So, the lower 48 states that is known as CONUS. Okay? CONUS. What does CONUS stand for? Continental United States. So, CONUS stands for Continental United States. All right? Now, if you notice on that last slide, Anchorage, or Alaska, and Honolulu, let me go back to it just for a second. Anchorage and Honolulu are identified as P, and then the identifier. Why do you think that is? I bet you know why, you just don't realize you know why. All right, so forgive my poor drawing here. But let's just say that this is the west coast of the United States. You know, you'll have Washington up here, and you have Oregon down here, and then you got Cali here, right? And then it goes on up into Canada, and then you got Alaska up here. Well, what is all out here? Everything out here is what? It's the Pacific Ocean. Now you got the chain of Hawaiian Islands down here, right? You got Alaska up there. You take the P from Pacific, and you've got P, whatever station is reporting in Alaska. You take the P, and you got P, whatever the station is reporting in Hawaii, okay? So that is why Alaska and Hawaii have a P instead of a K. Everything that is CONUS or in the continental United States will be listed on the identifier as K whatever, all right? So just know that if you see a P, it's either Alaska or Honolulu, or down in Hawaii, Honolulu, somewhere like that, okay? All right. So the date and time grouping, everything is identical to the Metars. So the 061730, it was issued on the 6th at 1737 Zulu. The second one there, the 121123, it was issued on the 12th at 1123 Zulu. Valid period, everything is exactly the same as the Metars, okay? So I'm gonna go through these slides and just leave them up for a second, and I'll let you just kind of sort of look at them and see that they are indeed set up just like the Metars. Now, here's the password for this week's quiz. Atis, A-T-I-S, all in caps. You will need to put that in just like every other quiz. It is a proctored quiz, so you'll need that password to get into it, okay? So here's our wind grouping, just like it is in the Metars. Now, prevailing wind direction is a forecast for any speed direction greater than or equal to 7 knots. When the prevailing surface wind direction is variable, variation in wind directions of 30 degrees or more, the forecast wind direction is encoded VRB, and then how fast, okay? Two conditions where this can occur are very light winds and convective activity. Variable wind direction for very light winds must have a wind speed of 1 to 6 knots inclusive. For convective activity, the wind group may be encoded variable, gust, and then the knots, where G is for the maximum expected wind gust. Variable is not used in non-convective low-level wind shear groupings, okay? Squalls are forecast in the wind group as gust, must be identified with the significant weather group code SQ. Examples: wind 230 at 10 knots. The wind is 230 true at 10 knots because we are reading it, it's true. 280, and then down the next one, the winds are 280, 20, gusting 35 knots. Variable VRB, 5 knots. Wind is variable at 5 knots. Variable 15, gusting 30 knots. The wind is variable, means it's changing direction by 30 degrees or more, and it's blowing 15 and gusting 30. When you see 0000 KT, that means the wind is calm. Visibility group's the same. Now, I want you to look at that very last line of this slide. P6SM, visibility greater than 6 statute miles. So let's go back to the board here just for a second, okay? I have seen in the past where students get confused by that P6SM. So I want to give you just a simple way to kind of sort of remember it, okay? So we know that if we see P6SM, that means it's greater than 6 statute miles, okay? I want you to think of it this way. It'll help you remember it, or at least it has shown to help others, okay? Think of the P means plus 6 statute miles. If you can get that in your mind to equate the P with plus or greater than 6 statute miles. If you can do it that way, it'll help you remember it, okay? Now, on these things, on a Taf, if the visibility is 10 miles, it's not going to say visibility 10 miles. It's going to say P6SM, okay? If the visibility is 30 miles, it'll say P6SM, okay? That's all it's going to say. So you need to know that and be aware of it. If the visibility is not expected to be the same in different locations, prevailing visibility is used. When volcanic ash, or VA, is forecast in the significant weather group, visibility is included in the forecast even if it's unrestricted at P6SM. For example, an expected reduction of visibility to 10 statute miles by volcanic ash is encoded in the forecast as P6SM VA. Although not used by the National Weather Service in U.S. domestic Tafs, the concentration CAVOK, ceiling and visibility OK, may replace the visibility, weather, and sky condition groups in all of the following conditions, if all the following conditions are forecast. Visibility of 10 kilometers or 6 statute miles or more, no clouds below 1,500 meters or 5,000 feet, or below the highest minimum sector altitude, whichever is greater, no cumulonimbus, and no significant weather phenomenon. So if all of those parameters are met, it may have the coded identifier is CAVOK, ceiling and visibility OK. So know what that, if you ever see that CAVOK, know that that means that the ceiling and visibility are okay. So there's again P6SM, that means your visibility is unrestricted. If you see 1/2 SM, that means your visibility is 1.5 statute miles. 4 SM, 4 statute miles. So let's look at some Tafs, all right? So this first Taf comes from the Papa Bravo Foxtrot Airport. That is the Pine Bluff Airport here in Arkansas. It was issued the 28th at 11:24 Zulu. This Taf is valid from the 28th at 1200 Zulu to the 29th at 1200 Zulu. The winds are forecast to be variable at 5 knots, greater than 6 statute miles of visibility, and the clouds are scattered at 25,000 feet. So the next one is from KSUA, Sierra Uniform Alpha. It was issued the 28th at 11:20 Zulu. It's valid from the 28th at 1200 Zulu to the 29th at 1200 Zulu. The winds are forecast to be variable at 3 knots, greater than 6 statute miles of visibility, and the clouds are forecast to be scattered at 4,000. Now, Here comes where Tafs can get tricky. Now they have different groupings, okay? You'll have a from category that tells you, in which we're about to look at, from this time to this time, this is what it's expected to be. Or from this time to this time, this is what it's expected to be. So know that if you see FM, that means there's a change in the weather. And you need to pay particular, look at that real close. Okay, so let's look at it. Now on KSUA, from the 28th at 1500, the winds are expected to be 07 at 7 knots, greater than 6 statute miles greater than 6 statute miles visibility. Clouds are scattered at 3,000 feet, and then there's another layer scattered at 5,000 feet. But then from the 28th at 1800 Zulu, the wind changes to 100 at 10 knots, greater than 6 statute miles of visibility, but there's showers in the vicinity. The VC stands for vicinity, and the SH stands for showers. There's a scattered cloud layer at 4,000 and a broken cloud layer at 6,000. And then we go into the 29th, and then from the 29th at 0100, the winds are scheduled to be, or predicted to be, 130 at 5 knots, greater than 6 statute miles of visibility. There's a scattered layer at 4,000, a scattered layer at 7,000, and there's not an amended Taft scheduled. That's what that AMD, not sched, amended Taft, not scheduled. Okay, now let's look at KJAX. That's kilo, my mind just went blank. So KJAX, JAX, on the 28th at 11:35 Zulu. This TAF is valid from the 28th at 1200 Zulu to the 29th at 1200 Zulu. That is there is that 24-hour TAF. If you look up at the first one, it's 24 hours. The second one's 24 hours. This third one is 24 hours. The winds are predicted to be 290 at 7 knots, greater than 6 statute miles of visibility, a scattered cloud layer at 1,500 feet, and overcast cloud layer at 2,200 feet. But then there's a change. From the 28th at 1,700, the winds are predicted to be 290 at 8 knots, greater than 6 statute miles, but there's a broken layer at 5,000. But then it changes again. From the 28th at 2,300, the winds are predicted to be variable at 4 knots, greater than 6 statute miles of visibility, and there's a scattered layer at 10,000 feet. So, for whatever reason, this got messed up, but I want you guys to pay attention to what I'm about to say. When you watch this recorded lecture, I will know if you've made it this far into the recorded lecture for this very reason. At this point in time, I want you, when you see me at the airport next time, say, hey Shannon, will you print me out a listing of all the abbreviations so I know them? And then I'm going to print them out and give them to you. If you do not come to me and say, hey Shannon, will you print me out the abbreviations for the Tafs and everything, then I know you did not watch this lecture all the way through. All right? So I'm not going to go over these. You need to come see me, that way I can print these out and physically hand you a copy of them, okay? Now let's look at the Atis report. Now, we do not have an Atis report here at Melbourne. We're not big enough to have an Atis report, okay? So the Atis report stands for Automatic Terminal Information Service. Now, this automatic service is a provision of current routine information to arriving and departing aircraft throughout the 24 hours specified in the portion of the Atis. Now, data link Automatic Terminal Information Service, DATIS, the provision of the ATIS via data link. All that means is you can get it via data link. Voice Automatic Terminal Information Service, or Voice ATIS, the provision of ATIS by means of continued and repetitive voice broadcast. This is what you will listen to over the radio. Excuse me. So contents of the Voice ATIS broadcast they normally contain the following information in the order listed. It's going to normally contain the name of the aerodrome, arrival and or departure indicator, contact type if communication is by, or contract type if communication is by DATIS, the designator, time of observation, type of approaches to be expected, the runways in use, status of an arresting system if they have one, potential hazards if there are any, significant runway conditions, and if appropriate, braking action. They'll tell you if there's a holding delay, the transition levels, and other operational information, surface winds in magnetic degrees because it's coming from the ground, speed, significant variations, surface wind sensors related to like low level wind shear, things of that nature, indication of the runway and the section of the runway for which the information refers. So that's talking about like if part of the runway has poor braking action, they'll tell you that. Visibility, runway visual range, present weather, clouds below 5,000 feet or below the highest minimum sector altitude, whichever is greater. If there's cumulonimbus clouds, if the sky is obscured, vertical visibility when available, air temperature, dew point, altimeter setting, any available information on significant meteorological phenomenon in the approach climb out areas, including wind shear, and information on recent weather operational significance. The trend of the forecast when available, and specific ATIS instructions. Now, I'm going to come back and put myself back on the screen just for a second. I don't want you to get too bent out of shape about these ATIS reports, okay? They're very simple. When you are asked, and you will be asked, what's an ATIS report? Very simple answer. You give this answer, I'm going to shut up. An ATIS report gives you all pertinent information about that specific aerodrome. That's it. You tell me that, I'm going to shut up. I may say, well, yeah, you're right. Now, you just give me a few things that are in it. What runways are being used, if there's any special weather, wind shear, things of that nature. Good deal. I'm gone. All right? So just know what's involved in an ATIS report. All right, so use of ATIS. An important element to the ATIS broadcast is the designator identifying code. It's that four-letter identifier that we talked about in everything else today. You will listen to the ATIS prior to contact and note the code. Now, how many hours are in a day? There's 24, right? How many times is a Tafs, or when's a Metar issued? 55 minutes past the hour, right? So does that tend to make you think that there might be 24, in some airports there might be 24 ATIS reports? There are. But how do you know if you got the current ATIS report? Well, each ATIS report is denoted by an alphanumeric, and it's just alpha code. Okay? Each ATIS report has an alpha code assigned to it. So whenever you hear an ATIS report, you'll hear something along the lines of, on initial contact, advise you have information alpha, Bravo, Charlie, India, whatever, okay? This is how the controllers, ATC, know that you have the latest up-to-date information. Now, as you're flying along, you might hear air traffic control come across and say, attention all pilots, blah, 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 information alpha or information bravo or whatever the next identifier is now current. So if you've already listened to the weather or the Atis report and got, say, information Charlie, and then you hear information Delta is now current, now you have to go listen to the Atis report again, get the most current information, check back in with ATC and tell them I've got information Delta. That way they know you have the latest information, the most up-to-date information about the airport where you're going. All right? All right, so in some cases, operated procedures predicted on RT communications safety requires that both pilots and multi-crew aircraft remain on the principal ATC frequency once the aircraft is flown below 10,000 feet. This means that ATC must pass any significant changes to the Atis report, okay? And they will do that over the airways. So there are regulations that state that below 10,000 feet, you have to, in the bigger jets, that you have to stay on frequency with ATC. Well, how are you going to get updated information if you can't leave the ATC frequency? ATC will provide that to you, okay? So guys, I hope this helps you understand just a little bit more about the different type of reports that we have to deal with in aviation. Now, you have the password for this week's quiz, and make sure to do your discussion post for this week and have all of that turned in no later than 11:59 this Saturday evening. And I look forward to seeing you guys at the airport. I look forward to reading your discussion post, and we will see you next time. I hope you guys have a great day. Bye.